Hi, Advanced Algebra 2. Welcome to the Concept 31A, or Part 1 notes. We're going to be looking at geometric sequences and series. So in a geometric sequence, the ratio of any term to the previous term is constant. This constant ratio is called the common ratio and is denoted by R. A ratio is a multiplier. So in example 1, tell whether each sequence is geometric. So we're looking for a common multiplier from one term to the next. So to get from 6 to 12, we multiply by 2. From 12 to 20, we do not multiply by 2, so we're going to stop. This sequence does not have a common ratio or multiplier, so that is a no. Oh, all right, let's back up here a little bit. All right, so now let's look at B. So we're looking for a multiplier. 256 to get to 64, we can divide by 4 or multiply by a fourth. 64 to 16, multiply by a fourth. 16 to 64. So we have a consistent multiplier or ratio. So that means that is a yes. This is a geometric sequence. Our ratio, constant ratio, is 1/4. Now, here's how to write a rule for a geometric sequence. Think of this as your formula. So the nth term of any term of a geometric sequence, a sub n, equals the first term, a sub 1, times that ratio, that multiplier, raised to the n minus 1. And remember, that n is your position number. So here's an example. The nth term of a geometric sequence where the first term is 2 and then the ratio is 3, so not e, the common ratio is 3, would be this formula, a sub n equals 2 times 3 raised to the n minus 1. So let's change that there. All right, let's write a rule for the nth term, and then we're going to find a sub 8. So we have our sequence in problem A, 5 to 15, that's multiplied by 3 again to get to 45 by 3 again. All right, so we can identify our first term and our common ratio, a sub 1 and r. So now we're going to use that formula that we just talked about to write a rule. So any term, a sub n, will be our first term, 5 times our ratio, 3 raised to the n minus 1. So the position number before. Now let's find the 8th term. So that means we will plug in 8 for n. So to find the 8th term, we take 5 times 3 raised to the 7th power, which gives us 10,935. Let's try B. So now let's see if we can find a common ratio, a multiplier. Remember, multipliers can be fractions, and they can also be negative. So 88 to negative 44, I'll multiply by negative 1/2, by negative 1/2, and by negative 1/2. So my first term is 88, and my common ratio is negative 1/2. So those are the two things I need to know to write a rule for my geometric sequence. So let's write the rule. So a sub n, any term, equals our first term, 88, times our ratio, negative 1/2, raised to the n minus 1. Now let's find the 8th term. So a sub 8 equals 88 times negative 1/2 raised to the 7th, or negative 6,875 10,000ths. Let's look at example 3. Now let's write a rule, and we're going to do for a geometric sequence when we're given a term and a common ratio. So again, we're going to use that formula and just kind of work around what we know and what we don't know. So our first term, our fourth term is 12. Our common ratio is 2. And then here comes the formula. All right, so we're going to use all this to plug in what we know and find out what we don't know. We don't know the first term, and that's what we need to know in order to write the rule. So we're going to work backwards from the fourth term and find the first term. So using that formula, a sub n, we're going to plug in 12. And then we don't know our first term, so that's a sub 1. We know our ratio is 2. And then since we're working with the fourth term, we do 4 minus 1, which is 3. Now we'll just solve for a sub 1. So we'll divide by 8, and a sub 1 is 3/2. All right, now we can write our rule because we know the first term and we know our common ratio. So our rule is a sub n equals 3/2 times a ratio of 2 raised to the n minus 1. Now the question is, what would this graph look like, the first 6 terms? So what's going to happen is it's going to be doubling each time. So we'll start slowly and then pick up speed. And you know this pattern. This is an exponential pattern. All right, now we're going to change it up a little bit. So we're going to use that formula we learned at the beginning, but we're going to write a rule for a given sequence when we're just given 2 terms. So we're going to set up a system of equations, okay? So we know our second term, a sub 2, is 12, and our fifth term, a sub 5, is negative 768. And then we know our formula, a sub n, equals our first term, a sub 1, times the ratio raised to the n minus 1. So using our second term, let's set up an equation. And I'm just making a note that we're going to use a system of equations to solve. So instead of a sub n, we say 12 equals a sub 1 times the rate raised to the 2 minus 1, because that's our position numbers is 2. So that becomes r to the first power. And now using our second, the fifth term that we know, we'll start with negative 768 equals the first term times the rate raised to the 5 minus 1, or 4 power. All right, here's my system of equations. I am going to use substitution, and so I'm going to solve for a sub 1. So a sub 1 equals 12 over r sub 1. Now I'm going to take that value and plug it into my second equation. All right, multiplying, so our r's will divide out and we'll be left with negative 768 equals 12 times r cubed. So I'll fix that in a moment. So 768 divided by 12 is negative 64, taking the third root. So now we know the rate, which is negative 4. That's our multiplier. We need to find our first term, so let's use our equation that we have solved for here and plug it in. So a sub 1 equals 12 over negative 4, a sub 1 equals negative 3. So now writing our rule, our first term's negative 3, our ratio is negative 4, and then raised to the n minus 1. Now we're going to find the first 6 terms. So I'm going to plug in 1 to this formula, negative 3, and plugging in 2, we'll get 12. I'm doing this pretty quickly. So again, I'm plugging it into this formula right here. So when I plug in 3, I get negative 48. Because my ratio, my multiplier is negative, notice how my terms will alternate positive, negative, positive, negative. All right, so there we have the first 6 terms in our sequence. And you can see that those values they jump. They also are going negative, positive because of that ratio. All right, now here's how to find the sums of a finite geometric series. So I've given you, if you look at the bottom of this box, you'll see the formula here, that the sum of a given number of terms, n, equals the first term times 1 minus the ratio raised to the n over 1 minus the ratio. This is a little tricky to execute on your calculator, but we'll practice in class and I'll help you so that you can make sure that you work this formula accurately. So how to find the sum? Here we go. So what we need to know is the first term. So let's plug in 1 to our little rule out to the side, and we'll get 4 times 3 to the 0 power, which is just 1, which is 4. Now let's find our last term, so that would be a sub 10. So plugging in, we're going to pick out our ratio, our multiplier, and that is 3. And then we're going to look for how many terms we have, which is 10. And that's what we need to know to work the formula. So our sum formula, and this is the sum of 10 terms, equals our first term times 1 minus our rate or our ratio raised to the 10th power over 1 minus the ratio. All right, so I do this on my calculator. I kind of piece it together, right, rather than plugging it straight in. So I will work with the numerator first and do 1 minus 3 to the 10th. Then I will divide that by my denominator, which in this case would be -2, and then multiply by 4. So do that and see if you can match my sum, 118,096. All right, this is a pretty difficult one, so let's go ahead and jump in and see if we can tackle it. So it says L is the loan amount. We're going to solve a real life problem, in dollars, and then it should be I, lowercase I, is the monthly interest rate in decimal form. T is the term in months, and then we're going to calculate a monthly payment. That's what capital M stands for, on a 5-year loan for $20,000 with an annual interest rate of 6%. All right, so we have to do a little bit of math gymnastics here. So it's M equals that 20,000 over the sum of this series right here. So a couple things is that a 5-year loan, that is 60 months, okay? Because notice that I is the, that T is the term in months, okay? So our sum down in our denominator is going to range from 1 to 60. Now, what's going to happen here is that our formula is 1 over 1 plus I. Now notice that I, and it's capital, but it should be a lowercase here in our, there we go, is the monthly interest rate. So we have been given the annual interest rate of 6%. So we're going to divide that by 12 to find the monthly interest rate. So that would be 0.005 or 5 thousandths. So we're going to add that, and now we're raising that to the K power. Okay, so first, our first term, and now we're just focusing on the denominator, and we're going to find the sum of this series. So our first term, when we plug in 1, is just 1 over 1 and 5 thousandths, and then our rate is also 1 over 1 5 thousandths. All right, now the formula goes our first term times 1 minus our rate, and sorry, that rate should have a 1 by it here, raised to our K power, or the top power, so 60th, over 1 minus 1 over. All right, now this is a little difficult to do on your calculator, so I have shown you what I do first with that little red number 1. So first I divide that and raise it to the 60th power. Then I do 1 minus, and I pull back that answer in my calculator. Then I divide it by my denominator, and I put that in parentheses, and then I multiply it. So now we'll take that number, and you should have gotten around 51.73 if we round. And when you divide that by 20,000, you will get a monthly payment of $386.62. If you're at home watching these notes, when we get to class, or when you get to class, we'll go over this on the calculator, and I'll help you figure out exactly how to make this formula work. This is kind of like a little extra, little bonus advanced problem. Let's find the sum of these, okay? We'll wrap up these notes. So we're going to use that sum formula. So that what we need to know is our first term, so we'll plug in 1 here, and our first term, well, it just went away. So when we plug in 1, we just get, and then we get 1. So the sum would be 1 times 1 minus our rate, which is 5 to the 8th power, and then over 1 minus 5. So putting that on your calculator, again, piecing it together, doing this top numerator first, then you're dividing by your denominator. See if you can get that sum. Now for B, we've got this geometric sequence. So our first term, when we plug in 1, we just get 6. And then our ratio is, our last term is negative 192, and then our ratio is negative 2. So finding the sum of the 12th term is 6 times 1 minus our ratio raised to the 12th power over 1 minus a negative 2, which is the same as 1 plus 2, and that will give us negative 8,190. All right, finally our first term, when plugging, is negative 16. We really don't need to know our last term. I'm finding it anyway. Our ratio is 0.5, so now plugging it into the formula, the sum of these 7 terms is negative 16 times 1 minus 0.5 to the 7th power over 1 minus 0.5, which will also just be a half. And then you should get negative 31.75. All right, that concludes our first part of our Concept 31 notes.